I'll admit to you, I was working without the camera. Sometimes I do that. Sometimes I need some time to myself. It's okay. Hi, everybody. Adam Savage in my cave. I was working on my powered hacksaw because I need it, and it's been sitting around here for too long. And I was cutting some threads for it, and they just weren't working out. They were like super not working out. They were like repeatedly not working out. It is 2 o'clock, and I have spent the day trying to single point some threads, and it hasn't been working. Let's talk about threads for a second. This is a piece of threaded rod. You know it as a bolt. One of the oldest inventions and one of the 6 simple machines the screw is. It is a circular climbing incline plane. It's a wedge, it's a lever. It's almost all the 6 simple machines in one. But these are threads. We all know these. We use these all day long. And when you want to cut threads, there are a multiplicity of ways. But the ways in which a home machinist might do it are just a few. If you want to cut an internal thread, that is, you want to cut a thread that's inside a hole, that's an internal thread, and you would use a tap for that. This tap has threads that match the threads that I'm trying to cut. These are 2 different threads, but that doesn't matter. I would use a tap that matched the threads I want to cut. I would drill a hole, spec'd on a chart for what's the right size of hole to drill. And then this has threads that have been cut like a normal screw, but it's been ground and hardened after having these 4 channels cut out. And what that means is that as this tap turns, this leading edge here is a chisel that carves out the threads. If I want to cut an external thread, this is an external thread. Well, I can use a die, and this is a die, and it is effectively the same kind of mechanism. Threads have been cut internally, and then voids have been cut out of the threads that lead to cutting edges. This one has 5 sets of cutting edges. This one has 4 sets of cutting edges. So taps and dies are the first way everybody who cuts threads learns how to cut them. And these are very reliable for the basic sizes. They're fantastic. But for anything non-standard, you want to cut your own threads. And it's a key part of a machinist's journey. I'm a machine operator. It's a key part of a maker's journey for me to cut my own threads. And this is, you cut your own threads with a thing like this. This is a thread cutter. It's got a little point here. That point is cut to exactly 60 degrees, which is the point of imperial threads. And you chuck a piece of round rod into your lathe, and you literally single point. You put that point in, and you make your lathe cut it. Now, how does your lathe cut it? Well, okay. So the business end of the lathe that you've seen is mostly this carriage, which affects the tool, and the spindle here, which holds the work. And you use the carriage and the spindle to spin the work and drive tools into it and affect it. But there's all these other rods going on down here, and these are for timing and for screw cutting and other types of complex engineering. How does the lathe know at what speed? So, what you do is you put a piece of rod in here and you set the lathe to the standard you want, to the threads per inch you want to cut. And it makes sure that the spindle spins at a specific speed, and so does the carriage. And that they work together. And I'm about to show you how this works at a first pass. But what I want to tell you is the problem I've been having. The drawing I'm working from, that it's a 5/8 thread. There are 2 types of 5/8 threads, 5/8 11 and 5/8 18. There are also, in other industries, probably many more. There are so many different kinds of threads, so many different kinds of nuts and bolts. It beggars the imagination. It is probably mathematically impossible to literally calculate how many different kinds of threads and nuts and bolts there are in the world. There are just too many. But in America here, when you're going for a 5/8 shaft, you're going to cut either 11 or 18 threads per inch in it. And that's what those 2 taps look like. And I've been attempting to single point 18 threads per inch. And I've been failing. And I failed twice before I decided to pull out my thread checker. This is a thread checker. It's got all these little shoes on it that have bumps, and those bumps have numbers, and each of those numbers is a certain amount of threads per inch. So for instance, that is 18 threads per inch. You can actually see the little 18 on it. There you go. That's 18 threads per inch. And I'm about to do a scratch pass in this piece and check and see whether it's actually 18 threads per inch, because even though I've said it, it might not be there. So let me take you on first I want to show you. This is the chart by which you adjust the threads, the pitches of cutting on your lathe. There are many different versions of this. In a lot of lathes, you've actually got to open up the back and put new different gears in. The gear shift between metric and imperial is real. This, luckily, is a big fat tool room lathe that has all the settings without having to change gears. And so let me turn the camera around and I'll show you how we do this. All right, so up top, here are some of the lathe settings. These are spindle speeds. These affect the automatic feeding of the carriage or the cross slide. This is the carriage travel. That's the cross slide travel. It doesn't matter for us today. This is low speed and high speed. This is also low and high. Yeah, rabbit and turtle. And then down here, we've got these guys. And there's ABC. There's OPQ, there's WXYZ, and then there's 1 through 8. So I want to cut an imperial thread. Oh, that's not metric, that's millimeter. It's this one, inches. I want to cut an imperial thread. So the first thing is X, X, X. So we go here to X. That one's X. Then we come down here and we look for 18. There it is. LB3P. 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 So we go here, we go to the L. Then we set this to B, and this to P, and this. Hold on, I got it. Sometimes I have to spin that in order to get this to set. This whole thing is full of gears. In fact, this arrangement is effectively a kind of a mechanical computer. So now I have 18 threads, 18 LB3P. LB3P XX. All right, we are correctly set. I've got a piece of anodized black aluminum in here. I'm just going to bring this up to... Sorry, I accidentally cut it and the camera wasn't rolling, so I'm just going to cut it again so you can watch it cut. Here we go. Great. And I'm just going to bring it in. This is the first part of threading anyway. It's called a scratch pass. So let's zoom in. Here we go. Excellent. Now I engage the threading feed handle. And it starts to cut me a scratch pass. There we go. So now the question is that 18 threads per inch? Okay, we have 18 threads per inch. And just to double check, when I check it against a tap that is 18 threads per inch, did own the money. Check this one out. Not on the money. Look at that. It's wrong. I'm going to go one down since it looks like it's a bigger thread. What the hell? What the hell, lathe? What is going on? What is going on? This is crazy to me. So that establishes pretty clearly that when I'm trying to cut 18 threads per inch and I set my lathe to cut 18 threads per inch, it says, great idea, boss. I'm happily cutting 16 threads per inch. Then I went and I Googled this. And it turns out that on the practical and home machinist forums, it seems to be that almost every lathe that has a complex chart for threads has a couple that are not right. I don't know about you, but I'm shocked. I'm also not necessarily surprised. It's a mechanical computer. There's a lot of moving parts. But the question is, does my lathe cut 18 threads per inch? And how can I get it to cut 18 threads per inch? That's what I'm now going to do. Why don't I try at the bottom and just start logging threads per inch and see what's right and what's wrong and see what they are. And then I may have to change some of the numbers on the chart. That's where I think I should go with this. I was planning to do something else today, but the best laid plans and all. Okay, so here's what I'm going to do is I'm actually going to work my way through this chart. I'm going to start at the lowest TPI. I'm going to see if the problem is my settings or something else. We're going to go down to low speed. 2 threads per inch. What's happening is that wasn't 2 threads per inch. It's 500 thou per thread. And that was like 450 thou per thread. That was not okay. Okay. I am confused. It seems that none of my settings are correct, which tells me that either there's like a gear that's not engaging or one of my settings is wrong. And between those two, it's more likely the second one that I'm wrong, not the machine. But I'm going to have to research what can be done. Yeah. It's very peculiar. I have an idea. I have an idea forming in my brain. So, we have an issue with my lathe in that in none of the settings of thread pitches that I have on my chart am I actually getting the said thread pitches it says I should get on this. That's unexpected. So I went home and I'm going to guess that some of you watching already understand the next step of what I'm going to do. It took me overnight. I was like lying in bed last night and I was thinking, okay, what is the information that I have? The lathe is a mechanical computer. This computer, when set to cut a thing, is not cutting that thing correctly across the board, which means there's a flow chart of different settings, and whatever setting is wrong is like at the top of that flow chart, is my assumption. Now, these levers that move back and forth here, each of these are moving. There's literally like a crank at the other end of this on an arm, and it's shoving gears into enmeshment. That's literally what these dials are all doing. They're moving one gear from here to here and enmeshing it with a different set of gears. And through that enmeshment and the changing of the number of teeth that are being engaged, I get to change the speeds. But the reason I'm bringing that up is that these levers, they don't get out of alignment. They look like, actually, when I hurt my finger at the beginning of COVID, it was specifically because this lever was actually missing the far right-hand setting. I couldn't get it into that setting, and I knew that meant that there was something slipping inside. And when I opened it up, this is like got like 5 gallons of oil in there, and the whole gear train sits in the oil bath. And when I finally drained all the oil and I looked down, there was a thing holding a gear, and and the bearing inside the gear was actually slipping out of it, and it was inhibiting that gear's ability to go as far as it needed to. I don't think this problem is that kind of problem. I think that would affect one of the settings, but not all of them. So let us take a look at the various dials. 1, 2, 3, 4, 5, 6, 7, 8. There are 8. And of them, 7 of them are of one kind and 1 is of another. You see where I'm going with this? This one is a wheel. It has 7 settings. I think it has 7 settings. I think the wheel is at the wrong setting. What I mean to say is, this handle that is a dial that moves a shaft, I think it might be misset on that shaft. So what I'm going to do is I'm going to chuck a piece back into the lathe. I'm going to move this setting one at a time. I'm going to choose 20 threads per inch, something I can easily see. And then I'm going to put this on the correct setting, and then I'm going to move it and cycle it through all 7 settings. And if one of those gives me 20 degrees, let's just say that the setting for, actually, I can tell you, the setting for 20 threads per inch would be 5. Okay, so I'd have this on 5. If everything is set up correctly with this, then 5 plus the other settings should give me 20 threads per inch. When it doesn't, because it won't, because it didn't, I would then simply try cutting 20 threads per inch on 4, 3, 2, 1, and then 7, 6. All the other possibilities. And if one of those possibilities gave me 20 threads per inch, the next thing I do is pull this wheel off, set it so that that's 5, and that, in theory, should then fix all the others if I have surmised the correct place that the impropriety is happening. That's the theory. I really want to wrap this up because I need this thing working. I want to get to some lightning. I've got some stuff to do. Lightning, making things lighter, not lightning. B L B 5 P X. Now, just to double check, that should be 20 threads per inch, but in what we've been dealing with, it's going to end up being 22, I believe. But I'm just double checking all of that. 18, it's 20, and it's not that, and there's 22, and boy, it is it. Like, you can just, the moment you get the right TPI, threads per inch, you can tell. Okay, so now, 20 is my goal. Okay, that's not 20. Yeah. That ain't 20. Okay, here comes 2. That ain't 20. 101. Can you tell I'm happy? I'm kind of happy. I'm excited. We haven't solved this problem yet, but we've gotten somewhere, which is that while this said at position 5 on this dial, I should get 20 threads per inch. Instead, I got 22. So that tells me that where position 1 is currently is actually position 5. That's the theory. So I'm going to pop this, see if I can't, and do the, and get the going. There it is. That's what I was looking for. So, new theory. So this is, I thought this might be held on with a spline shaft. That was my goal. That was my hope, because a spline shaft would allow me to move it and clock it, etc. But that's not the case. It seems to be held in with a roll pin, which is a cylinder with a slot cut out of it, and it's made out of spring steel, and you push it in, join two things together on a shaft. Creates an excellent resistance to shear force. But and that seems to be how this is held on. But a roll pin means that there's one hole on each part, and they marry, and I don't feel like popping a roll pin out of this. I mean, I guess I could right now. Oh, let's see how hard it is trying to do that. Okay, so right now it's horizontal here. So it's got this this slot here. Sorry, it's got this slot here, and it's sprung to be ever so slightly bigger than the hole you're putting it in. And that means it's resistant to removing itself even from vibration. So now that I've pulled this and it's horizontal, I should be, yes, I can, and I did. If 5 should be 1, then I'm going to just put a piece of tape on this that changes all these numbers. And then I'm going to try them out. The fact that this can't be easily reconfigured tells me that deep in here, inside here, a bearing, a shaft to bearing relationship might have shifted. To be fair, I'm not positive. I have single point cut threads. I have single point cut threads, but I've only done them for single point cut nuts that I have made. I don't think I've ever cut a single point thread that had to fit an existing nut. So I think this might be the first time I've realized that this is off. The question I'm trying to answer in my head is, did this happen before I got this lathe, or has it been something that's happened since I've had it? Because if I've never uncovered this problem before, but this is the first time I've tried doing this kind of thing, then that could mean that it basically got messed up in a rebuild years ago. Suffice to say, I am going to clock shift all 8 of these numbers and see if, once I do that and I start applying these settings, do I get correct thread counts? Okay. Yeah, I'm just going to clean this with a little acetone, put some tape on there. One thing you might have heard me say, wow, that's weird, is the fact that the hole in the shaft here is not through the center of the shaft. It's actually through the bottom of the shaft. So to describe what's happening here is normally a through pin you would pass a through pin through center like that. But this through pin is actually passed through the top like this. Like that. It's passed through there, not through the center of the shaft, but through one side of it. Why? When you pass it through the center, this can have 2 possible positions, which means it's possible to get it wrong. When you pass it through something other than the center, there's only one position this goes on the shaft. So that was meant to make this a non-screw-upable part. So if it's deep in here, I may someday tackle this. There's an oil port here. This is the oil evacuation port. This whole thing is full of oil. You know what? Let's see if this fixes the problem. And if it does, then I'll go in. If it doesn't, then it's something else. Okay. I don't know how to finish this project, but I now know what the next step is. 5 is position 1. Interesting. 5 being 1 means that this thing is 1/2 turn out of phase. That might be interesting information later. Oh, whoops, that's an idiot. There's our new dial. It won't end up looking like this permanently, but for right now, this is good enough. So let us get this guy. I think I just do that. No, 5. This should give me 20 threads per inch because that's a 1 underneath. This is boilerplate what I'm doing because I already know that this is 20 threads per inch. That's great. Now I want to cut some other value. Oh. Let's just choose a value at random. Let's choose 42 or 40. 40. Let's do 40. Actually, let's do 30. All of the whole numbers have the 5 in them. Okay. So then let's try a different number. Let's try 36. LB30. LB30, right. O. LB LB30. LB30. And that is 36 threads per inch. Okay. That's great. That's great. I should test one more setting just so I feel comfortable. I could have chosen the only other setting this worked at. Once I have chosen 3 settings and I get the correct thread pitch on all 3 of those, then I'll feel like I have something. That's just a test platform right there. So. Let's do one I couldn't hit before. 11, LB1Q. Remember when I said I looked up Google that like there are often one setting on here that's probably wrong? The first time I encountered this was trying to cut the 5/8 diameter 11 threads per inch nut that's in my tailstock here, the screw that's in my tailstock. And this cut 10 threads per inch. So let's try 11. I know I didn't tell you that story at the beginning because it happened a couple of years ago, and I've been meaning to shoot this video for a long time to try and suss this out. Anyway, 11. So 11 threads per inch is LB1Q. Wait, that's 11.5 threads per inch. That's 12. Hold on. There you go. That's 11 threads per inch. Let's see here. Deuteronomy. Boink, boink, boink. Within problem solving, there's the assessment of the problem. Then there's the naming of the problem, which is different. Then there's understanding where the problem lies within the system that it's a part of. And that can often be the most difficult part of solving a problem. And it's just figuring out like where the thing you're trying to fix fits in. And maybe by looking at it through that lens, it can help you understand. And the way I described thinking through this problem is exactly my favorite kind of problem solving, waking up in the middle of the night and being like, oh, wait a minute. And it's just about, all I'm doing is thinking about the system in different ways. It's actually, each of those ways is like a different lens. So I was thinking, well, how do I change the speeds? I change the speeds by moving gears. How do I move the gears? I move the gears with levers. Do I move all the gears with levers? I move most of the gears with levers. Oh, so there's a category that's not lever-based. Could that be a place where you could find a solution? Actually, yes. So it's actually like, idea-wise, it's like the eye doctor going, better or worse? How about this lens for looking at it? Oh, better or worse? Actually, can you see it clearer this way? And the same thing happened on, I built Stumped over the 3 days in the Exploratorium's courtyard here in San Francisco a few years ago. And it was not working. And I had 3 days to build it. I had pre-built all the linkages, but once I started assembling them, it wasn't quite working. And there was a guy who spent most of the 3 days watching me build. Actually, a whole bunch of people spent all 3 days watching me build it. There's one guy, and he was talking to one of my producers. And when I'm doing a live build in front of people, I try and filter them out. I want to just be in my zone. And I could hear this guy talking to my producer, and he had an idea about why it wasn't working. And I was just sort of like letting it pass by me and thinking, I appreciate that he wants to help. I don't want to engage with him. I'm just listening out of the corner of my ear. And then late that night, a phrase he had spoken made me remember something, and I realized, oh, he's right. I got this one thing wrong. This one thing I got totally wrong. And I could see it now. And I went in and I fixed that one thing, and bang, the whole thing worked. It was just the best. So what I've come to understand, this beautiful aluminum dial is exactly 180 degrees out of phase. So here's what I want to do, and it's non-trivial. Like I said, the actual pin for this goes through something other than center. So what I want to figure out, what I'm going to do is drill another hole on the other side. And that will allow me to clock this thing 180 degrees out of phase. And that should work on this. Yeah. I don't want to do that right now. I want to just lighten up my neutrino wand because that's just something that's been on my mind. But I can do this, and I should. I shouldn't just put stickers on these numbers. I should fix this permanently. If it turns out that there's a creeping problem on this in terms of the setting the thread pitch numbers, then I'll get around to pulling the drain plug, emptying this out of oil, pulling off this panel, going to work inside of that thing with the power off all the way until I'm done. Don't want to lose this finger again. Yeah, let's get to it. First step. So 180 degrees out of phase. That's what I want. 5 is 1 and 1 is 5. 5 is 1 and 1 is 5. So this is such a beautiful piece. Okay, so I want to figure out this hole. This, can you see me? Where is it? There it is. This hole. I want to figure out what diameter that hole is. And I'm going to do that with my gauge pin set. Now, you could get close by walking through your drill bits, but gauge pins are the shit. So here we go.
0.199 inches is about 5.055 millimeters.
5.1. That is a 5.1 millimeter hole. Let me see if I have a 5.1 millimeter drill. And I do. Okay. All right. So I'm going to get this into my mill. I'm going to get this into my mill. Can you see the... I'm going to chuck this into my mill. I'm going to clamp it, and then I'm going to make sure I know its center exactly. And then I've got that. And what I'm going to do is measure how far off center that hole is. And I'll know how far, when I set it up this way, to offset that hole. And then I'll re-drill it. Easy peasy. Hopefully. Hopefully. So like I had to start by figuring out the distance between the actual center and the center of my measuring ball. Then I remove that from this measurement and I get the measurement between the center and the center. And then I add half the distance of this shaft to get the through drill for this hole. So now I have a situation. So now what I need to do is mount this upright, perfectly vertically. I wonder if I have another 5mm rod. Let's see here. All right, so some more indicating. I now have the measurement I need. Oh, it's 1.17195. Okay, I'm going to let this go. That seems crazy. And I'm going to mount this like this and put this here. So technically, I think, now that I've got this smoothly going in here, all I need to do is move it over double the distance of my measurement. So 0.17195 and then 0.17195 again, because the first one will get me that this is the center, and the second one will get me to the other side. So in order to do that too, I want to mill a flat for my 5mm drill. I have 2 holes now. There they are. Look at them. I even got the light behind them. What a master of my craft. That was totally by accident. So I'm now going through a new hole. You have a new family now. I'm going through this new hole, and that should allow me to turn this dial 180 degrees out of phase. But first, I'm going to clean it up just a little bit. Okay, it looks like it's a totally clean through hole. So let's try and drive this puppy in and see if we can't get the result. Okay, so one end is narrower, that's this end. There's only one way to finish this video out, says my narrative brain, and that is choosing a thread we haven't cut before and getting it right. I hope that works. LA50. LA50. After all that, I put the pen through the wrong hole. I was getting the same messed up thing I was last time. Shall we try that again? These are my favorite kind of videos. A lot of you in the comments say that these are your favorite kind of videos. The videos in which I don't know how it's going to turn out. And it's an interesting thing, that tension. I'll be honest with you. In the middle of this video, which was at the end of the day yesterday, when I left here not knowing why the problem existed, I had isolated the problem. I'd identified the problem, but I had not yet identified where in the system the problem might be. And then left here yesterday really frustrated. Honestly, genuinely frustrated. Wondering, is this something I'm just going to have to live with? How am I going to fix this? And I'll be frank with you. There are times when I have like a problem to solve in here. I don't want the cameras rolling. I need my full mental capacity on the problem itself. And so there are classes of problems that I like solving on camera, and classes of problems that make me nervous about being on camera, specifically because I don't like being super frustrated in your presence. That's just like, I'm self-conscious about it. I recognize that it like makes better content and that it's more honest, and honesty is not just the best policy, but for me, it's the water that all my favorite YouTube channels really swim in. It's the water that all my favorite content of any kind really swims in. And what I mean by honesty is not necessarily just telling factual truths. It is being present with the thing. And if the thing is being on camera with me and I can see that person is there, I am there too. It's hard because when you're on camera, you're thinking about all sorts of other stuff. You're like remembering your lines and you're thinking about what you want to say. Why did I start recording this? I started recording this because this is my favorite of all kinds of outcomes that happen in this shop. The kind where I have an unidentified problem, I identify it and then fix it. Boom, just like nothing's better than that. But it's really hard to predict and plan for those kind of videos. It's nearly impossible. Of anybody in the filming of making things, I think I have among the largest amount of institutional knowledge of the ideas of projects that I can get done in X amount of time while cameras are rolling. But even still, with this one, I was like, I don't know if I want to keep shooting this one. This one's really kicking my ass. There's my 15. Here's the moment of truth. Hopefully. Hey! I could not be more happy about my lathe right now. I'm just so delighted. And what I'm going to do in celebration is I am going to I just received this in the mail from one of the Ghostbuster suppliers. Right now, I'm going to take this Neutrona one that I ordered, that is a tabla rasa, and I'm going to go through it and lighten it up so that it is a little more forgiving for the cosplaying and the trooping. Thank you guys for joining me for this one-day build. It has been a singular pleasure. This is my absolute favorite kind of day. I'll see you next time. Cheers.